A very good evening to one and all. Myself Vamshi. I am from the Tripoli branch. Today I am explaining about a topic of analytical design of PID controllers. Coming to introduction part of the analytical design of PID controllers, this is PID controllers are widely used in industrial control system for their simplicity and effectiveness. These controllers are used in many industrial companies because it has a simplicity and very effectiveness. Analytical design involves turning the collector parameters to achieve desired system performance. For the PID controls as a design which turning the control parameters to achieve the desired system performance. The key parameters of PID controller are proportional, integral, and derivative gains. These are the parameters. PID controller have three parameters. That's the proportional, integral, and the derivative gains. Importance of proper PID controller design. Proper design ensures stability and robustness of the controller system. There is a proper design which will gives stability and robustness of the control system. Analytical design allows for systematic turning based on mathematical models. A well-turned PID controller can improve system response time and accuracy. A good PID controller can give a quick response time and accuracy. Proportional gain in PID controllers. Proportional gain directly scales the error signal to produce the control output. This gain directly scales the error signal to produce the control output. Increase in the proportional gain can improve the response speed but may lead to instability. Proper turning of the proportional gain is essential for achieving desired performance. Proper turning for proportional gain is essential for achieving desired performance. Integral gain in PID controllers. Integral gain eliminates steady state error by integrating the error signal over time. It will be integral gain as it eliminates the steady state error. Too high integral gain can cause oscillations and instability. Proper turning of the integral gain is crucial for maintaining stability and accuracy. Proper turning of the PID controllers can give it is a very crucial role for maintaining stability and accuracy. And it is a too high integral gain, it causes to oscillations and instability, and it's eliminates steady states also. Derivative gain in PID controllers. Derivative gain anticipates future errors by calculating the rate of the error signal. It helps in damping oscillations and improving system stability. Careful turning of the derivative gain is necessary to avoid amplification. It have to be careful turning and a perfect turning to avoid noise amplification. Because of this, you can avoid a noise, and it also helps for damaging oscillations and improve the stability of the system for a year. To analytical methods of control design. These are the several methods. If I coming to first method, we have Ziegler-Nichols method. It is a popular historic approach for turning PID controller. Ziegler-Nichols, it is a popular and well-developed method for PID controller design. It is the best and one and only, and it is approach for turning PID controllers. Frequency response analysis and root locus techniques provides insights into system behavior. This response of frequency analysis and root locus techniques will provide insights into the system behavior. Model-based methods use mathematical models to optimize control parameters. Model-based methods use mathematical models to optimize control parameters. Ziegler-Nichols method for PID turning. Coming to brief in this method, Ziegler's method involves step response analysis to determine the critical and oscillation periods. It is the quick response for to determine the critical and oscillation periods seeds. Based on these parameters, proportionally in integral derivative gains are calculated. Based upon these parameters, these are proportional and integral, and derivative gains can be calculated easily. It provides a simple and effective way to tune PID controllers for different systems. It is a very easy and a simple and easy to do. It is a very effective and a simple, and it is used to tune PID controller for different systems. Frequency response analysis for PID design. Frequency response analysis helps in understanding the system's behavior in the frequency domain. Bot plots and nuclear diagrams are commonly used for analyzing stability and performance. By adjusting the PID gains based on frequency response, the controller can be optimized. For this, bot plots and nuclear diagrams are commonly used for analyzing stability and performance. By adjusting the PID gains based on frequency response, the controller can be optimized easily. Model based PID controller design. It is another method for the PID control design to tune. Model based design uses mathematical models of the system to optimize controller parameters. System identification techniques are used to estimate model parameters from experimental data. It is a technique for system identification for the parameters of the experimental data. By incorporating the system dynamics into the design process, model based methods can achieve superior control performance. Challenges in PID control design. There is many challenges for the PID controller design. And coming to first, non-linearities in the system can affect the performance of PID controller. Non-linearities in the system can affect the performance of PID controllers. Uncertainties in the system parameters may lead to suboptimal controller tuning. Integrating PID controllers with advanced control strategies. Integrating PID controllers with advanced control strategies can address these challenges. And these advanced techniques for PID controllers are many of them. We are coming to some of them. We are fractional order PID controller offer additional flexibility in handling complex systems. Adaptive PID control adjusts the controller's gain online based on system variations. Fuzzy logic and neutral network based PID controllers can adapt to non-linear and uncertain systems. Case studies of PID control designs are automotive industry uses PID controllers for engine speed control and cruise control system. PID controls are used in automotive industry for the purpose of engine speed control and cruise control system. Temperature control in industrial processes often relies on PID controllers for precise regulation. Aerospace applications use PID controllers for attitude control of aircraft and spacecraft, and is also used in the aerospace applications. Use PID control for attitude control of aircraft and spacecraft also. Experimental validation of PID controllers. Experimental validation involves testing the controller performance on a physical system. It involves testing the controllers on the performance on a physical system. Step responses, frequency analysis, and robustness tests are conducted to evaluate the controller. Comparison between analytical design and experimental results helps in fine-tuning the controller parameters. Best practices for PID controller design. It will be start with conservative gains and gradually increase for optimal performance. Validate the controller design through simulates and experiments before implementation. Continuously monitor and adjust the PID gains to adapt the changing system requirements. It is like continuously monitor and adjust the PID gains to adapt the changing system and requirements to the according to the requirement. There will be changes to that. And will be conservative gains and gradual increase for optimal performance will be best. And validity and the control design through simulation and explain before implementation will be very careful to before we are doing any experimentation on the implementation we have to implement. And the future trends in PID controller design, integration of machine learning techniques for adaptive control and optimization. Day by day our many of the techniques are introduced and developing day by day. Development of hybrid control system combining PID with advanced algorithm. Coming to future, we develop of hybrid control will be there with combining of PID with advanced algorithms. Real-time implementation of PID controllers using embedded systems for faster response. Thank you.